Hi class, let's talk about radiation fogs. Radiation fogs are one of the three fogs that form by cooling the air. The conditions under which they form, it's usually a nighttime condition under clear skies. It forms when winds are relatively calm, so either calm or very light winds. And we also start off with a high relative humidity. So those are the initial conditions. So under the clear skies, why that's important is that infrared radiation can leave the Earth's surface, head out towards space, and that will rapidly cool the air. So lots of outgoing terrestrial radiation, infrared radiation, that's going to cool the surface. Cool the surface rapidly. Okay, and as a result, when the surface cools rapidly, the saturation mixing ratio will decrease to the point that the saturation mixing ratio equals the mixing ratio. Okay, so when that happens, you get relative humidity equal to 100%. And under those conditions, fogs could form then. And so fogs will start forming from the ground, and the longer these conditions exist, typically the higher the fog will form. And so this fog, again, is a suspension of little tiny water droplets. And radiation fogs have certain conditions, certain characteristics. And so let's look at the characteristics. Okay, so the characteristics of a radiation fog are that they are a very shallow fog. There's not much depth to them. Typically, they're tens of feet thick. And so they're not a very dense cloud typically. They're very shallow, and they often will dissipate fairly rapidly, 1 to 3 hours after sunrise. This is a very common fog in Wisconsin, occurring any time of year. And oftentimes when they do dissipate, we use certain euphemisms for it, that the fog lifts or the fog burns off. So why we use those is that during the daytime then, once the sun comes out, so remember at nighttime it was clear skies, and so during the daytime when the sun comes up, there's not going to be any clouds around, and so the sun will shine down towards the surface, and in the daytime the surface absorbs solar radiation. And when the surface absorbs that incoming solar radiation, the surface is going to warm. And when the surface warms, that's going to increase the temperature of the Earth's surface. So the air temperature is going to, put it there, the temperature is going to increase. And when the temperature increases, the saturation mixing ratio increases. Okay, and therefore the relative humidity will drop. It will become less than 100%. We've got unsaturated conditions, and so the fog, it's going to appear that it's lifting off the ground. So the fog will dissipate from the ground up, And because it dissipates from the ground up, it looks like it is lifting. So there's our euphemism for the fog is lifting. Some people look at it as the fog is burning off. And so we use that euphemism for burning off because the temperature is warming up, the saturation mixing ratio is increasing, which drops the relative humidity to below saturated conditions. And without saturation, you can't have the fog. So, again, some people call it the fog is lifting because it's what it literally appears to do, or it just simply burns off. Okay, so that's radiation fog. Next, we're going to take a look at what are called advection fogs, and that's coming up soon.